Hey everyone, this is me making a quick video to help you with that practice exam. I will launch right into it. We are looking at beginning of the year skill, this number pattern thing. I did tack on this extra little wrinkle that brought in some skills from the end of the year or the end of try 2. But anyway, this first one is just saying, hey, if we have a tree that in it, when you plant it, that's really year 0, like when you're born. A year later, 1 year in, it's produced 3 walnuts, young little sapling that it is. 2 years in, 12, 3, 27, 4, 48, and so on. And it's all about just continuing this pattern. And if you do your carrots, you'll see quite quickly that it's going up by 6. These carrot numbers are going up by 6, so you get a constant after 2 rows. If we keep that pattern going and add 27 and then 33, we'll get 108. So know that. This part is like an extra bit that would be on a separate problem and spelled out maybe a little bit more clearly. So my apologies if this was bewildering to you. But when they say up here that it's a square variation, you've got to go back and say, oh, in year 1 we got 3, or in year 2 we got 12. You could use any of these as data points to solve for k in our square variation that walnuts is some constant k times x squared. When you plug in 1 or plug in 2 and check and see that you get 12 coming out, if we divide both sides by 2 squared or 4, we get k equals 3. No matter which data point we use, we'll get k equals 3. Then once you know that k is 3, whoops, down here, sorry, off camera. But once you know that k is 3 after plugging in the values, you can then take your year 50 that you want to predict and square that and multiply it by 3, and you get a whopping 7,500 nuts after 50 years, okay? Like I said, this one will be broken out and be probably a separate one, but I thought it was kind of a way to make a connection between the two different sections. So this one is a little bit more straightforward, right back to that first unit where we're looking at organizing things. Mathematicians do this all the time. They come up with a systematic way of thinking through a problem. How many ways can you make $21 using a $7 bill, a $3 bill, and a $1 bill, or keyback, or whatever they're called? So we've done this, and you know how to kind of think it through so that we're systematically going from the fewest number of bills down here to the most number, where we would use 21 of the smallest denomination coins at the very end. When you see this pattern that you're stuck at 3, and then it jumps down, you go 2 until it goes 2, 1, 0. Then you jump down from 1 and you go 4, 3, 2, 1, 0. And then you jump down again and you go 7 down to 0. It makes adding it up quite a bit easier, I think, okay? So you get just that final 21, all right? So then on to the next page where we're graphing lines, okay? So this is bread and butter stuff. Know how to graph y equals mx plus b. Know that inside out, top to bottom. The slope is your first value, could be positive or negative. You could have a standard form of a line. These are often easily graphed with this intercept method. Plug in zeros and plot the points carefully. If I let x be 0, up here my y value is a negative 10 to make that a positive 70. So when it's 0, I'm down here at negative 10, and then I'm at 14 comma 0 for that. I draw the line, I label it, there it is. Same thing for slope-intercept form, only slightly different. I start at the 6 and then I do the slope. I can go up 1 over 2. I could go up 3 over 6. I could go up 5 over 10 as long as it's in a 1 to 2 ratio. All right, and then I label that, and that's the slope-intercept method. Know about these 2 exceptions here, horizontal and vertical lines. A vertical line will say go out to some x value, in this case x equals 3, and then you can go anywhere in the y direction because there's no y at all. So that's the equation for that vertical line. Horizontal lines are always, where does that y hit on the y-axis? Where does that line hit on the y-axis? In this case, it's at -1, so that's simply the equation. And you can think of it as being slope-intercept where the slope is 0, whereas these slopes are called infinite or no slope, all right? Then down here, I tacked on an extra one like we did in class. If you're just looking at a graph, trying to write an equation, it's awfully nice when you're given the y-intercept. That's just the b value, so we can plug that in right there as my b value. I can see that my slope is up 1 and over 3. It's the rise over the run, so a rise of 1 and a run of 3, and I've got y equals 1/3 x plus 3. just to make sure you know the skill, I didn't put on this, but know how to take any 2 points and come up with the equation of a line. I like that arrow method where we start with the y values. -3 to 5 is an increase of 8. -1 to 1 is an increase of 2. This is a slope of 4. That's my m value. And then where's my intercept? You can see it off the graph here. If I go up 4, and over 1, I'll be right there. But you could also plug in either one of these points into like y equals 4x plus b, and then I can plug in 1 for my x value, 4 times 1 plus b, and I will get 5 coming out. And when I subtract 4 from both sides, I'll see that b equals 1. And so my equation for that other line would be y equals 4x plus 1. All right? So that wasn't on the practice test you did, but that's a good skill to add. All right? So then for 6, this is the last one on this page. If we're doing what's called a linear programming problem, you need to read it very carefully. We've got our extra cheeses and our why not add pickles to pepperoni, so we can define our variables, very helpful hint there. And then we're told that we can sell them for $18 and $16. That is not something you're going to graph. That's something that is your objective. You're trying to sell these to make a profit, or really it's just your income. You got to subtract the cost of making it, etc. But the constraints are the things that are governing how many you can make. You can only make a total of 100 pizzas. So that's your x plus your y. It has to be less than or equal to 100. And when you graph that, you'll be like this, okay? You won't be able to use Desmos, but you will be able to use your calculator. If you were to solve this, you could graph y equals 100 minus x. You'd get that line. But you can also just graph it by plotting points, just like we did with your x and y. And you'll see, oh yeah, it's 0 and 100, and it's 100 and 0. So it's easy to plot. These other lines are just x has got to be bigger than 25, and y has got to be bigger than 20. You get the vertical and the horizontal lines like we talked about. This final one, if pepperonis are always, if cheese pizzas are always more popular, x is always going to be bigger than y, then this is bigger in the x direction, and you're going to shade in this way to get this feasible region, it's called. After that, we just want to know what the corners are, and we can read that off of our graph. And when you know what the corners are, you can plug them in. When you know what the corners are, you can plug them in down here, and we can then evaluate that, oh, this corner at 50/50 doesn't make me as much money, only $1,700. If I plug in the one that has more cheese pizzas than pepperoni, I make more profit with them, so I'll make slightly more money on this one. All right, so that's that. Now on to our data one. All right, if you are studying the distance it takes, the distance you are from school versus the time it takes you to get to school, you can plot that data on a graph like this, and we've practiced these skills with our calculator. Make sure that you know when you are working with these things how to edit numbers, okay? How to enter them, how to clear things, how to re-enter data, and then most importantly, how to graph that and you actually get a graph to show up. Make sure that you only have one plot, often plot one turned on. You can turn things on and off by going up there and just selecting them. So I've turned that on. Now I can go up and turn that off if I want by hitting it again. To change the type of plot, I do second y equals, and then I can see that my lists are correct. You should know all these skills. There's lots of videos to help you. Once you graph that and you do stat and calc, and then do quad linreg number 4, and get an answer, just copy that down. But remember, that's your slope value and that's your b value, your intercept value. All you do is just copy that down. You can type it into your calculator, and your calculator can graph it. It'll be the line that best fits the data, and you can then make predictions, all right? So that's what that's all about. Using that equation and predicting if someone was 36 miles away, we would predict it would take them about 44 minutes to get to school. We can also say that if we know how long it takes them to get to school, about 16 minutes, we could predict that they're about 9.1 miles away. This is simple solving, but look at the steps and make sure you understand it. It'll be something similar to this on the exam. And that'll be what are called free response questions. After this, it gets to sort of multiple choice